So this example states, suppose an insurance broker sells a newly married couple a $250,000 one-year term life insurance policy for $375. The broker states that newly married couples have a 99.8512% probability of surviving the year, so they're off to a good start. Then we have these two questions here, A and B. What is the expected value of this one-year policy to the broker? And then B, what is the expected value of this one-year policy to the insured? So as we read any of these word problems, we have to make sure that we're reading them very carefully and we're clear on what's going on. The first thing I want to point out is the expected value here. So we're looking for an expected value. So in the long run, what can we expect to occur? Also, there are two parties involved here. For A, it says, what is the expected value of this one-year policy to the broker, to the one who is selling the policy? And then what is the expected value of this one-year policy to the insured, the people who are purchasing the policy? So as I glean over the scenario here, I have $250,000 here. I've got $375 here. And I've got a probability here of 99.8512%. And all those values are going to play a part in determining our expected value. So the first thing I like to do, I'm going to put A right here, is we're going to have some sort of payout. And that payout's going to have a probability attached to it, the chances that that payout occurs. One of the payouts, $250,000. So I'm just going to put it in right here. What is it, $250,000? Well, that's going to be a payout if the newly married couple does not survive. Now, though we have a probability here of 99.8512 that they will survive, we could determine that they won't survive by finding their complement. We just subtract that from 1. So the chances that the $250,000 payout occurs, that's going to be the complement. That's 0.001488. Now, since this expected value is representing the broker, if they survive, if the couple survives, then what is the payout for the broker? Well, he doesn't pay anything out, so that's going to be 0. So that's the key to make sure we know what is occurring. I want to represent this table that represents the expected value to a particular party. So he's not going to pay anything. And what's the chances that he doesn't have to pay anything? Well, if they survive. So that's going to be 0.998512. And of course, our probabilities should total to 1. That's a good rule of thumb to make sure that we've got everything covered. So now that we have this, we go ahead and we multiply this to this, and then sum it together. So we'll take $250,000, multiply to its probability, add that to this payout here, but since this payout is 0, 0 times anything else is going to be 0, I'm not going to add it on there, but I think you get the idea. So this comes out to be $372. So what does that mean? That means that the insurance policy costs $375. The broker, in the long run, he's going to take that money and he has to invest it so that it grows into the $250,000 policy. So that's going to be $375 minus $372. And that comes out to be $3. So what does that mean? So that means in the long run, what is the expected value? Or in the long run, what is the expected value of this one-year policy to the broker? He can expect to make $3 on every policy he sells. Now for B, what is the expected value of this one-year policy to the insured? It's the same idea. Put down B right here. We're going to have a payout. We're going to have a probability of a payout occurring. We have a payout of $250,000. The probability of making that payout, that's 0.001488. Except this is, what is the expected value of this one-year policy to the insured? Well, the insured had to pay $375 for the policy. So if they don't survive, they get $250,000. If they do survive, that's 0.998512. They just spent $375. So they're going to be out to $375. And again, don't forget, this has got to be, probability's got to total up to 1. So this table here represents the expected value to the broker, and this table here represents the expected value to the insured. So we do the same thing, $250,000, multiply it to its probability, and we already know that it's $372, but we're going to do this anyways. Multiply the negative 375 to its probability and add it to this. So this comes out to be negative $2.44. So how do we interpret that? Well, they paid $375 for the policy. However, eventually somebody in the long run is going to get the $250,000. So if I subtract out the $2.44, the actual cost of the policy to the newly married couple is $372.56. $372.56. So the key is to make sure that we're addressing the correct party if there's more than one party involved, and to make sure that we're utilizing all the values that are expressed.